climate scientists claim that humans cause global warming. This is controversial. There are those who cannot imagine how that could be or don't wish it to be. So let's examine a few bits of evidence, some data, that explain to us how scientists can make that claim. There is controversy about global warming. Some say it doesn't even exist. Some deny that humans play any role in the problem. And yet, professional climate scientists do feel and do hold this claim that humans are at least partially responsible. And then other folks claim it's just a conspiracy. Let's take a look at actual measurement data. Let's look at the facts behind the claim that humans cause global warming. Well, it's a fact that coal and oil contain carbon. It's a fact that this carbon was absorbed millions of years ago by ancient plants. It is a fact that if you burn coal and oil, that burning is a chemical reaction. It's a chemical reaction where carbon combines with oxygen, resulting in the formation of carbon dioxide, which is a gas that escapes into the air. These are all incontrovertible facts. You can measure the amount of carbon in the form of carbon dioxide that has been put into the air by humans over the years. This graph goes back to 1750. And as you move forward, you can see that sometime after 1850, the amount of carbon putting into the air started to rise dramatically. This is coincident with the Industrial Revolution. And since then, the amount of carbon going into the atmosphere, put there by humans, burning fossil fuels, has gone up higher and higher. You can follow the increase in carbon into the atmosphere by separately measuring the concentration of carbon dioxide in the atmosphere. This chart shows you that the concentration at about 280 parts per million has been constant for the last 1,000 years until very recently, when it starts to shoot up. This increase in the presence of carbon dioxide in the atmosphere follows the same upward path as the earlier chart showing the amount of carbon put into the atmosphere by humans burning fossil fuel. Here's another chart showing the similar information. Now we have, going back 2,000 years, over 2,000 years, we can see that the amount of carbon dioxide in the atmosphere was relatively stable, and then all of a sudden shoots way up. As a consequence of all this carbon dioxide in the atmosphere, we can expect that there should be some heat absorption through the behavior of carbon dioxide. The next graph illustrates this. We are looking at a plot. The red line shows you the heat emission from the Earth if it were a simple object in space, absorbing heat from the sun and radiating it outwards. In fact, the Earth is not a simple object. It contains these gases. Notice that near the top of the curve there is a huge dip. It looks like a chunk has been taken out. This is the absorption band of carbon dioxide, showing that the carbon dioxide molecule, very well understood, absorbs heat coming into the Earth and radiates that heat in the form of infrared heat radiation, not only outward into space, but also backwards down to the surface of the Earth. This is a behavior of carbon dioxide that's well understood. There is nothing mysterious about it. It's a fact. Now, as a consequence, it's a smoking gun. Humans put carbon into the atmosphere in the form of carbon dioxide. Carbon dioxide's behavior is very well known. It absorbs heat, therefore we have what we know as the greenhouse effect. People put the carbon dioxide into the air, therefore people are contributing to global warming. Let's look a little bit further. Let's take a look at the fingerprints on the gun. In order to do that, we have to take a look at isotopes. The carbon atom has 6 protons and 6 neutrons. Therefore, it's called carbon-12. This is the common form of carbon. 99% of all natural carbon is regular carbon-12. However, there is some carbon with an extra neutron in the nucleus. That is called carbon-13. Both of these forms of carbon are stable. They are called isotopes. You could add another neutron into the nucleus of carbon and you would get carbon-14, yet another isotope of carbon. Carbon-14 is radioactive. We won't be dealing with that here in this particular story. Now, in the atmosphere, you will find a small amount of carbon-13. It's about 2%, 1%. Most carbon, as we've already mentioned, is common carbon-12. However, plants have a curious characteristic. Plants absorb carbon dioxide. They give off oxygen, but plants have a slight preference for carbon-13. Plants will absorb a few percent less carbon-13 than is the normal ratio of carbon-13 to carbon-12 in the atmosphere. Therefore, we can make a prediction. If you take carbon that has been absorbed over millions of years in old ancient plants that preferentially excluded some carbon-13, and if we put that carbon into the atmosphere, what do you expect to happen? You would expect that there would be less carbon-13 in the atmosphere than normal, because you're getting old carbon from the olden days and putting it up into the atmosphere. In fact, this is what is measured. If you measure the ratio of carbon-13 to carbon-12, you find that over the years that ratio has been declining. There is less carbon-13 in the atmosphere than you would normally expect. This is a fingerprint. This is the fingerprint of human beings, because it takes people burning fossil fuels to put that older carbon into the atmosphere, therefore causing a reduction in the ratio of carbon-13 to carbon-12. This is a fact. The ability that scientists have to make measurements on these very tiny differences is itself quite amazing and very impressive. Now let's go further. We have found a fingerprint on the smoking gun. Let's take a look for the DNA of guilt. So there's another way of digging deeper into the carbon story. As carbon is burned to form carbon dioxide, it's coming out of the air. So we would expect there to be a reduction in the amount of oxygen in the atmosphere. Now that effect is very small. You don't have to run around looking for oxygen masks. It's not going to cause a problem for us oxygen breathers. However, if you take a look at the measurement data, you will see that just as is predictable, as we burn carbon, we reduce the amount of oxygen in the air, necessarily, because it's being used up in combining with carbon to create carbon dioxide. It is very interesting and very important that the amount of reduction of carbon in the of oxygen in the atmosphere is coincident with and appropriately the right rate of change as you would expect from the burning of carbon and the increase of carbon dioxide in the atmosphere. The oxygen content drops as carbon is burned. Now, this is a very complicated looking graph, but it tells an interesting story, the same story as we've just noted. The horizontal axis is CO2, concentration of carbon dioxide in the atmosphere. The vertical axis of this graph is the concentration of just oxygen. If you go to the very top, you'll find the date 1990, and you can track yourself downward, 1991, 1992. As you go down, you are looking at the decrease in oxygen in the atmosphere as a result of burning carbon, forming carbon dioxide. Look next to that line and you will see an indication of the degree to which fossil fuel burning increases the concentration of carbon dioxide in the atmosphere. When you get to the bottom, You then go backwards, reducing some of that carbon dioxide in the atmosphere because the ocean absorbs some of it. You go backwards again, and you will find some more absorption taking place over the land, and you end up back where we ended up with it at the year 2000, showing that the amount of oxygen consumed, therefore the reduction in the oxygen in the atmosphere, is just the right amount to be accounted for by the increase in carbon dioxide in the atmosphere. What does all this mean? Well, it makes a simple prediction. This is a prediction now, based on the measured amount of carbon put into the air, based on the rate of increase of carbon dioxide in the air. Knowing what carbon dioxide does, it absorbs heat. Recognizing from isotope ratios that it is people putting the carbon up there, we can predict that the atmosphere of the Earth must be warming up. And in fact, that's what the measurement data show. Here we have the global average temperature across the atmosphere of the Earth, the overall global average, and you see that the trend is clearly up, just as we would expect. Now, when you measure the global temperature change from year to year, from decade to decade, you will notice many fluctuations. It's quite complex. And this is due to other factors. Humans putting carbon dioxide into the atmosphere is not the only reason why temperatures fluctuate. Volcanoes will have an effect. Even large weather patterns like La Nina and El Nino, and so therefore you will get substantial fluctuations up and down. And in fact, if you were to say, look at 1940 and up to 1970, you would see a downward slope of the heat curve. And if you were unfair and non-scientific, you could look at that and claim, oh, this shows that there is no global warming, it is global cooling instead. But that's not correct, because you have to look at the entire time, the entire interval of humans putting carbon in the atmosphere to see the long-term average effect going up and up and up. Here's just one example of the impact. Here we see a plot showing the reduction in ice mass in Greenland. There are many, many other types of impacts that could be shown, but I don't have time to do that. I'm just showing you one example, measurements showing the consequence of global warming. So we have to come back and conclude as a fact, humans do cause global warming. You can't get away from it. You can't deny it. You can't pretend it away. You can't say that it's all a matter of conspiracies or emails or whatever. You have to accept that the facts show it. Now, humans aren't entirely responsible for the entire greenhouse effect on the Earth. We need the greenhouse effect. We need to keep the Earth warm enough so that water stays water and people can grow plants and harvest potatoes and breathe and eat and so forth. If we didn't have any greenhouse effect at all, the Earth would be a cold, frozen, miserable place that life would be very difficult to enjoy. However, the increase in temperature as it goes on, the constant continual burning of fossil fuels, will ultimately have a very serious negative effect on the planet as a whole. That would be the story for another time. If you want more information, you can go to realclimate.org, which is an incredible website where you will find actual real global climate scientists offering the very latest information as to what research is showing. You can also go to the IPCC website, the site of the Intergovernmental Panel on Climate Change, where you will find the combined knowledge of thousands of research scientists looking at this entire problem from all aspects. Some of the charts in this presentation came from a wonderful website at the State University of New York.